So, Unity. Will you blend? Break. Anyways, I started by setting up a quick test scene using Lightweight and downloaded Graphy, which is a really solid asset store plugin for measuring performance. I also made sure to turn off VSync to avoid my frame rate getting capped at 60, and with that, it was particle time. So I started with Shuriken, Unity's CPU-based particle system, and as I expected, it handled 10,000 particles without breaking a sweat. Of course, all these tests are going to depend on the hardware you're running. My build is on the screen now. Next up, I tried with 20,000, then 40,000. Still, the average FPS was above 200. Now, just to clarify, the particle system here is using the standard billboard rendering settings with no forces applied other than a start speed. I also noticed that I was getting a huge performance increase when playing the simulation with the game view maximized. Probably because Unity is removing a lot of engine overhead in this case. So I continued doing this throughout testing. Next, I doubled the number to 80,000. Then 200,000. At this point, the simulation was finally starting to slow down, and at 400,000 my FPS had dropped to 25. So I decided that 400,000 particles might be enough. So that's pretty much it for this Oh, you want more? Well, so did I. So after putting together a quick graph to show the decrease in FPS based on particle count, I was ready for round 2, the visual effect graph, or Unity's GPU-based particle system. First, I installed the package and set up a quick graph based on the default swarm template. As you can see here, it uses simple quad rendering and the particles are moving using a vector field force block. So here is 400,000 particles running using the effects graph. No problem. The same thing can be said for 1 million, and 2 million, and 5 million. All hail modern graphics cards. In fact, the biggest problem was to get my screen recorder to capture all the detail without slowing down the computer too much. At 10 million particles, my frame rate finally dipped below 25. At first I thought, we have reached the end. 10 million is the highest we'll get. But then again, maybe we could do something to optimize it. So I started by simplifying the movement of the particles. I tried making them completely static and just spawning them randomly within a sphere. However, to my surprise, this had pretty much zero impact on the FPS. At 2 million particles, my frame rate increased from 117 to 118. Not ideal. Next, I tried spawning all the particles from a point and then applying a spherical velocity. Again, no difference. At this point, I concluded that movement wasn't the thing slowing everything down, so instead I moved on to rendering. Here I messed around with a bunch of settings, like soft particles, ways of setting color, and different blend modes, all with no significant change. Not until I tried making the particles opaque. This immediately doubled my frame rate. Of course, rendering opaque sprites at this size just makes everything look like tiny dots. So I changed the renderer from quad to point, and all of a sudden I could run 10 million particles at 150 FPS. This might be the time I've been most excited about optimization. Like, ever. Of course, discerning individual particles from each other is really hard with point rendering. Currently it just looks like one big black dot. So to solve this, I added a combination of vector field forces and turbulence and changed their color based on noise. I think that definitely looks a lot better, and as we discovered earlier, these factors don't really impact frame rate all that much. So I increased the amount of particles yet again to 20 million, and then 50 million. And here it seemed like we'd squeezed out all the particles my computer could handle. I also tried lowering the graphics settings, disabling lights, as well as post-processing, all of which had no impact at all. I even tried changing to HDRP, which only made it worse. Finally, I had the idea to try and create a build which would allow me to close the Unity editor and run the simulation as a standalone. With that and all the other performance enhancing settings I could think of, I managed to squeeze out 80 million particles at around 20 FPS. It isn't pretty, but I guarantee you they are there. So feeling pretty satisfied, I showed all of this to Andreas, who slowly turned to me and said,
"Well, that's all fine and dandy, but can you make it rain?"
We shared a telepathic moment. I slightly raised my eyebrows and with a smug smile I replied, yes I can. And that's pretty much it for this video. If you enjoyed it, make sure to subscribe and ring that notification bell so you don't miss the next one.